Tuesday, we saw the easiest of problems because both domains for what were the functions, m of x and g of x, were all real numbers. There weren't any restrictions. So if you compose two functions whose domains don't have any restrictions, well, guess what that new composition is going to have? A domain of all real numbers, because there aren't any restrictions to consider, yeah? So today what we're going to do, we're going to practice composition yet again, but I feel like, especially after the homework, we're pretty decent at that, yeah? Okay, especially after D, right? But it's really the domain we need to focus on. So let's look at example number 3. And I'm going to color code again, although in first period I messed up. So hopefully I don't mess up. No promises. And we've got f of x and g of x. Well, for A, it's asking us to find the composition f of g of x. Remember that g of x is going to be substituted into f. G of x is our input. All right, so I'm going to, like we did on Tuesday, just rewrite this so I have the visual of what I'm substituting in to f. So I'm going to, what the heck is that? I'm going to rewrite this with my g of x inside. Okay, and f of x happens to be a fraction, so there's only one variable, and that's in the denominator. Let's go ahead and take 2 over, substitute in 2 times the square root of 12 minus 2x, and then minus 4. I put the radical in a parentheses just as a reminder that that's the function we substituted in. That's our input. And notice in the denominator there is a greatest common factor. What is that? 2. Perfect. Let's factor that out. Ultimately hoping to reduce. So that leaves us with the square root of 12 minus 2x and then minus 2 on the outside. Friendly reminder about radicals. You cannot take anything out of a square root unless it's a perfect square. And in this particular situation, we have a quantity underneath the square root, which means that I'd have to take it from both terms. The only GCF we could pull out is a 2, but 2 is not a perfect square, so there's no purpose for us to simplify the radicand, the value under the radical. All right, our 2's can simplify, and that leaves us with f of g of x being equal to 1 over the square root of 12 minus 2x minus 2. It's not pretty, and it's a little uncomfortable, but the directions didn't ask us to find a composed function that's pretty. It's okay if it's weird, or at least not common. Pardon me. Okay, any questions on the composition piece? Nothing else we can simplify, so let's move on to the domain. Remember that we talked about on Tuesday domain checks. In other words, where do restrictions possibly come from? They come from a fraction, because what can the denominator not be in a fraction? Stephen?
0.
0, because then our function becomes undefined. We cannot divide by 0. Also, if there is a square root, because what can you not take the square root of? A negative. Both will create restrictions, and, hey, we have both here. Now, for the domain, it does get a little tricky because you're putting two functions together. I need to find the domain that satisfies both functions and their possible restrictions. So what we're going to do is we're going to go through this one using a 1, 2, 3 system. I'm going to show you, okay, here's what we do first, second, third, and then hopefully that'll help you as you're going on with the different functions. All right, here we go. Not ideal spacing. Sorry, I need to rearrange. Fudge. We're going to do the following. The domain of f of g of x. In other words, what's the domain of the composed function? The first thing that you want to do is find the domain of the inside function. Okay, the first thing that you want to do is find the domain of the inside function. So for us, we want to find the domain of g of x. G of x is a square root. So we're going to take 2 times the square root of 12 minus 2x and figure out what makes that greater than or equal to 0. It's greater than or equal to 0 because only positive numbers are greater than or equal to 0. So let's divide by 2 on both sides. We get the square root of 12 minus 2x is greater than or equal to 0. How do we get rid of a square root? What is its inverse operation? Stephen? Squaring. Okay, so let's square both sides. So 12 minus 2x is now greater than or equal to 0. Subtract 12 with me, please. So we get a negative 2x is greater than or equal to negative 12. Now what do I do? Divide by negative 2. And what do we have to remember? Tegan? Flip the sign. If you are dividing or multiplying by a negative number, you must switch the inequality. If you are somebody that forgets that, please write that down. All right, so if we divide by a negative 2, we find that x is less than or equal to 6. This is the domain of our inside function. It will be included in our final answer, so I'm going to highlight it as a reminder that I must include that domain. Okay, step 1, find the domain of the inside function. Step 2, find the domain of the outside function. And truly, what we're looking for are restrictions only. Okay, so we're going to find the domain of f of x. And what we're looking for is any restrictions that it may have. Now, f of x is a fraction, so where would the restrictions come from again? The denominator. What can the denominator not be? 0. So we are going to take that denominator and set it not equal to 0. What can x not be? 4, right? Yeah, it can't be 4 because that will make our denominator equal to 0. So this particular function has a domain of all real numbers except x cannot equal 4. So step 1, find the domain of the inside function. Step 2, find restrictions on the outside function. We found one. We have a restriction that x can't equal 4. Well, pause for me for 1 second and look up at example 2b. And I need you guys to buy in with me on this one, okay? Is it true that when we had k of 3, we went and inputted 3 into the function of k? Was that right? That was our input, correct? Okay. And we simplified down, and we found that the output was negative 17. Is that correct? Okay. We then took the output and substituted it into the outside function, right? So the output of the first function then became the input for the second function. Is that a valid statement? Yeah. The output for the first function then became the input for the second function. So why does this matter? Because the output of our first function cannot be a restriction for this second function. say it one more time. The output, the y value of our first function can't be a restriction for the input of the second function. Okay, so what we do in step number 3 is we're going to take our first function, I don't know where I am, there we go. We're going to take our first function, which is 2 times the square root of 12 minus 2x, and we're going to set it not equal to the restriction of the second function. It cannot equal that restriction because then our function won't exist. All because of that reasoning we just talked about. The output of the first function cannot be the restriction for the input on the second. Okay, whew, it's a lot. It's a lot to wrap your mind around, but let's solve. Let's see what happens. Let's divide by 2. So we get the square root of 12 minus 2x cannot equal 2. Now what do I do again? Square both sides. Okay. So we're going to square both sides. And we end up with 12 minus 2x cannot equal 4. Subtract 12 with me, please. So we get a negative 2x cannot equal negative 8. So what can x not be? 4. Same as a restriction. That is just a coincidence, everyone. So this answer where x cannot be 4, that must also be included in our final domain. The results from numbers 1 and 3 are what we're going to put together for the domain of our composed function. How do we do that? Just like we did back in October. You're like, October, huh? What? Yeah, just like we did back in the day. We're going to create a number line. We know it has to have 4. We know it has to have 6 because those are the numbers in numbers 1 and 3. Now for number 1, x has to be less than or equal to 6. Well, that means I'm going to include 6 and every number less than it. Number 3 says I cannot include 4. Since these overlap, we're going to have to include them both in our domain. So the domain of f of g of x is going to be this. X is less than or equal to 6, not equal to 4. Or, for those of us getting more comfortable with interval notation, working left to right, we're going to say that it goes from negative infinity to 4, non-inclusive. That is a restriction. We can't include it. Union, non-inclusive 4, inclusive 6. Okay, so first, find the domain of the inside function. Number 2, see if there are any restrictions on the domain of the outside function. Step number 3, set the inside function not equal to the restrictions from number 2 and solve. Questions? Okay. Yeah, Courtney.
I just want to make sure. So
Sure.
when we, so if the properties were switched, the third one would be an inequality rather than a not equal to.
Excellent. Yep.
Okay.
Great question. You'll actually see that in the next example.
I figured that was so much.
Oh, no, I'm glad you asked. Thank you so much. Other questions? This is sort of a pat your head and rub your tummy kind of thing because you have to switch your way of looking at the different domains. So let's do another example, everybody. Hello, example B. We're still using f of x and g of x And this is that other formatting that we talked about. Goff and fog, right? And I was like, don't call it that. Well, if this looks uncomfortable or weird to you, you can always rewrite it as g of f of x. I personally prefer this because it helps me to see the input rather than g of f. But again, personal preference. So I'm going to substitute in f of x into my notation. So 2 over x minus 4. And then I'm going to go ahead and substitute it into g of x. So that leaves us with 2 times the square root of 12 minus 2 times. Here's where we're substituting in the function f of x. So I'm going to put in 2 over x minus 4. Now again, just like we discussed previously, there isn't a perfect square that we can factor out. So you can leave it like this, or you can multiply the 2 and the 2 in the numerator to get 2 times the square root of 12 minus 4 over x minus 4. Either one's acceptable. Okay, questions on the composition piece? Alrighty, let's get to the new part, the part that you are loving so much I can see it in your eyes. Let's find the domain of g of f of x. We've got this, everyone. Step number 1, find the domain of the inside function. So we're going to find the domain of f of x. And we actually already found it in A. We know that it's all real numbers except x cannot equal what? Yeah. So this has to be included in our final answer. Now, for step number 2, we need to find the domain of the outside function. In other words, we're looking for the restrictions. So, question, if g of x is 2 times the square root of 12 minus 2x, it's a square root. It can't be negative. How could I set up an inequality to find its restrictions if it cannot be negative? Normally, when we're finding the domain, we set it to be greater than or equal to 0. Peyton? No, you're good. If we're finding the domain, so to find the domain, we set the square root to be greater than or equal to 0. But if we need to find the restrictions, we're going to set the square root to be what? What is the opposite of greater than or equal to 0? Peyton? You're so close. Do I want to be equal to? Ha ha ha! We are going to set it to be not less than 0. We have to negate it because we don't want to be this. We're trying to find, nice job, the x values that our function cannot be. Okay, so let's set this not less than 0. Let's find the restrictions. Go ahead and divide by 2 with me, please. So we get the square root of 12 minus 2x cannot be less than 0. What do I do again here? Nah, square both sides because it is the inverse operation of a square root. So 12 minus 2x cannot be less than 0. Subtract 12 with me, please. So we get negative 2x cannot be less than negative 12. What can x not be? Why do you say greater than?
Because when you divide it by negative,
Excellent. Yes, when you divide by that negative 2, we have to switch the sign. So x cannot be greater than 6. This is the restriction on the outside function. We need to know what values of x will create these numbers, anything greater than 6, as an output for the inside function as y value. So step number 3, we're going to take f of x, which is 2, over x minus 4, and we need to know what's going to make this greater than or equal to 6. Okay, just like we did in the previous A example, we set the inside function to the restrictions found in 2. Oh man, you guys, there's a variable in my denominator. How do we move x minus 4 to the other side, Stephen?
Multiplication.
Love it. Yes, let's multiply. Multiply both sides by x minus 4 so that it cancels on the left. We end up with 2 being not greater than 6x minus 24. Add 24 to both sides with me, please. So we get 26 cannot be greater than 6x. Well, I don't know about you, but this makes me uncomfortable. I don't like x being on the right side because I'm reading it from left to right. So I'm going to switch everything, yeah? I'm going to say that 6x cannot be less than 26. Is everybody all right with that? Okay. Now, last final thing, divide by 6. So x cannot be less than 26 over 6, which if we reduce is 13 over 3. What is that in decimal format, approximately? Ah, nice, everybody. 4.3 repeating. And this is also going to be included in our domain. Okay, the results from numbers 1 and 3. We need to see if they overlap, how they overlap, so we can write our final answer. Here we go. The domain of g of f of x. I'm going to draw my number line. I know that I need a 4 from number 1 and that we need a 4.3 repeating from number 3. Now, personally, I'm going to start with number 3 first. In A, we started with number 1. It doesn't matter, but usually you want to start with the inequality first, okay? The inequality says that we need to be that we cannot be less than 4.3. So what does that mean? If I can't be less than 4.3, what can I be? Greater than or equal to. Yes, it can be greater than or equal to 4.3. So we're going to include it, and we're going to include everything that's greater than. Number 1 says we can't be 4. Do these overlap? No. There's no way that we can be 4, so we don't need to address it. The restriction found in 3 already applies. So we can say that x is greater than or equal to 4.3 repeating, or we can say that it is inclusive 4.3 repeating to infinity. Yay! Good stuff, good stuff. Okay, any questions on B? All right, I'm going to have you, for the try this, or the you try, do the composition on your own and then we'll walk through the domain together. Is that okay? Yeah, okay, so go ahead and do the composition. Okay, hopefully, as I cough, hopefully we have 2 over negative square root of 4x plus 32. Why do I feel like I did that wrong? Because I totally did. Oh my gosh. Did anyone out there catch it? But you didn't say anything? Note to self, if you're in need, don't count on Steven. Just kidding. You were just waiting for me to figure it out. Yeah. Thanks. Oh, golly. All right. Sorry, everyone. Here we go. So we have the negative square root of 4 times 2x plus 3 plus 32. Can we factor out a GCF from both terms in the radicand, the quantity under the radical, that is a perfect square? Ah, yes, good. If you can, you must. So we have negative square root of, they both have a 4 in common, so we end up with 2 over x plus 3 plus 8. What's the square root of 4? 2, yes. So our final answer should be a negative 2 times the square root of 2 over x plus 3 plus 8. Is everybody all right with that part? Okay. All right. Domain. For the domain of k of m of x. Here we go. First step, we need to find the domain of the inside function. So we're going to find the domain of m of x. What's the one restriction on m of x? What can x not be? Negative 3. It's whatever makes the denominator quantity equal to 0. So x cannot be negative 3. Therefore, we know it's all real numbers. X cannot equal negative 3. This has to be included in our final answer. Step 2. Find any restrictions on the outside function. The outside function is k of x. It is a radical. It is a square root. So, looking back at our handy dandy, where did I write it? To find domain versus to find restrictions, we're going to take the square root and set it not less than 0. What's going to make our radical having to deal with a negative? So negative square root of 4x plus 32 cannot be less than 0. Yeah.
So for the one where it's all real and then x is k equals negative 3, how do you know it's all real? Is it just...
You assume that every function has a domain of all real numbers and then look for restrictions. Yeah, thanks, Chloe. Okay, divide by a negative with me. We get the square root of 4x plus 32. This cannot be now greater than 0. Square both sides, so 4x plus 32 is not greater than 0. Bless you. We're going to subtract 32, so 4x cannot be greater than a negative 32. What can x not be greater than? Negative 8. Okay, that's the restriction. That leads us to step 3. We need to know what values of x are going to make 2 over x plus 3 greater than 8. So 2 over x plus 3 cannot be greater than negative 8. All right, similar to what we saw in the previous example, let's multiply both sides by x plus 3. The denominators cancel out. We get that 2 cannot be greater than negative 8x minus 24. Add 24 with me, please. So 26 cannot be greater than negative 8x. But again, I really don't like having x on the right-hand side, so let's switch or flip everything so that negative 8x cannot be less than 26. Dividing by negative 8, what do we need to remember to do? Excellent, everyone, yes. So x cannot be greater than negative 26 over 8, which reduces to negative 13/4, which is what in decimal? Yes, negative 3.25. God bless America. I never get used to that. Sorry to everyone on the notes, that must have been terrible because it was for us. Okay, if x can't be greater than negative 3.25, what must x be? Think opposite. If it can't be greater than, beautiful, less than or? Equal to. Perfect. So this is also going to be included. I'm going to try to go through this like super fast just in case we do have to evacuate the classroom. For those at home, we're jealous that you're sitting on your couch. Okay, so negative 3 and negative 3.25. Here we go. Those are the two values from numbers 1 and 3. That's why they're on my number line. As I mentioned in the last example, we want to include the inequality first. It just saves us a little bit of confusion trying to figure out what to include. So x has to be less than or equal to negative 3.25, yes? The restriction is that x cannot be 3. So, yep, open circle, good. Overlapping, when we put these together, I'm just going to use interval notation. We're going to go from negative infinity to negative 3, non-inclusive. Ooh, what did I do, Courtney?
This is a negative. Yeah, that's on the other side.
Thank you all.
Yes. I think what happened is I got frazzled by the false alarm. Your math teacher doesn't know how to set up a number line, but I'm glad you do. Good work. Okay, so we were saying that it has to be less than, I quit, but it can't be negative 3. Teach yourselves. So now that it's correct, do they overlap? Oh, fantastic. So I'm just going to say that it goes from negative infinity to negative 3.25 inclusive